Alrighty, well, for some inexplicable reason, people seem to enjoy watching me code. So I figured I'd make a video of myself upgrading this last utility. I've got this list of utilities, and I've been checking them off as I go. I've got this one here that I haven't checked off yet, but it's because I haven't finished writing it yet. Otherwise, I've checked off all the utilities that have already been written, with the exception of this very last one, about C64 OS. And on this side here, I made some notes to myself about all the steps I need to carry out to upgrade a sort of standard utility to make use of the new utility framework. So here we go. So I'm going to load in about C64 OS .a. That's the source code file. So I have to include the new utility framework header. So that'll bring that in. And along with that, I need to remove this utility include, which was not a header. It was actually a body. It was a static chunk of source code. So I'll get rid of that. Yeah, so by getting rid of that, rather than having that static chunk of source code get embedded into this utility, the utility framework is now a separate chunk of code that gets loaded independently of this utility. So that's a big improvement. So next, in order to support the integration between the utility framework and the utility, I've taken this exports table and extended it. So I have been changing my options comment here to just say extended exports. The comments are obviously, you can use whatever comments you want, but I tend to have sort of these sections that I keep in the same order so that I know where I'm going as I write my utilities. So first thing I'm going to do here is I'm going to go down here to my config section. And so one thing is I'm going to get rid of this config file name because I used to have an identifier for the utility, so about C64 OS with the spaces. And then in addition to the identifier, I also had this conf file, which is all lowercase, no spaces with a .i at the end. And then I was also hard coding down, way down at the bottom. I was also hard coding in the actual oh god, I'm not exactly sure where I am there. Color map, hold on. Char map, about app. Yeah, so I was also hard coding in the title that appears at the top of the utility in the title bar. But now the utility framework does all that stuff for you. Now in this particular instance, about C64 OS, sometimes if a utility is very narrow, but the name is quite long, sometimes I use an alternative shorter name. But we can look at that. We can look at that later when I get to that part. But the point is that now everything is based on the identity. So the title can be based on the identity, and also the config name can be based on the identity. All it does, the utility framework basically takes the identity, strips the spaces out, lowercases it all, and sticks a .i on the end, and boom, that's the standard config file. So we can ditch this config file. Now I'm going to search and see if conf size is actually being used by anything. Because if it's not, I'm just going to get rid of that, put that number straight into the exports table. Now, okay, so as it happens, I am actually using conf size somewhere else in the code. So we can go back to the label conf size. But what I am going to do is I'm going to move it out of this little section and up to my exports table. So move that up there. Now, the new exports consist of the screen layer, the draw context, the toolkit environment structure, but this utility doesn't use the toolkit. So I used to have these constants here for various options. So is toolkit used to be read by the old static file for conditional assembly. Now I don't need that, but in this header here, I would put a pointer to the toolkit environment, but since this utility doesn't use toolkit, I can simply put null. And usually I put a comment here that says not toolkit based. Next is our a pointer to where the config data starts. And lastly is a byte, not a word, is the conf size. Okay, so we don't need that. We also don't need these two static options. But what I'll do is I'll move them down into the init section here. Just to, we'll come back to that. That's just to remind myself of what options I was using, but we'll see that we're going to have to change that. So that's it for the extended exports. Now we'll come down here actually to config. So I've changed. It used to use conf start. I don't know why. I changed that just to config. Okay. Another kind of cool thing is the new utility framework auto detects changes to config. So all you have to do is change a config variable, and when you close the utility, it auto detects changes to the config, and it'll save automatically. You used to have to use a property called conf_dirty, and if you modified the config, you would have to also explicitly set conf_dirty. So I'll just search for conf_dirty. I don't think it's in use in this utility, but you know, if it were, I could get rid of all the conf_dirty references. Okay, so there's no conf_dirty in this particular utility. Okay. So, so this exports table, these pointers just point to these various structures. So here's the screen layer that we point to, here's the draw context we point to, here's the config that we point to. The reason why this table is necessary is because, you know, where you put this identity and how long it is and what other things you put, you can put a bunch of other variables in here, and so where you put the screen layer and where you put the draw context exactly in the code is not reliable. However, this export table always must come in this order, starting at util base. Okay, so the next thing I need to update is all these screen layer pointers. So draw main was the old name that I used to use in the static file. I can search for that by label, but I'm not going to find it because I know that draw main came from the old static file. So I'll search for that by label. I didn't find it. Search by label back to my screen layer. So this is a super easy transformation. I simply changed the pointer from draw main to uf draw. UF is utility framework. Next, we have this pointer to proc mouse. So for utilities that are 100% toolkit based, it's all of the mouse handling can be done by utility framework, and you can simply put in here uf pmouse for proc mouse, or pmouse actually, like this, pmouse. Okay, for this utility, which is not using the toolkit, it has to do a little bit of keyboard, a little bit of mouse event handling manually. So I'll just pop down here to proc mouse. However, all of this crap that I used to have to include in every utility, this is basically just, what do they call this? They call this boilerplate code. the switch statement that switches the down, track, and up to do drag start, drag do, drag end. That's for dragging utility. That's all boilerplate stuff. That's all handled by the utility framework now. So in order to get, so what I was saying is that if this utility was 100% toolkit, I could simply put in the screen layers structure UFP moose. But since I need to do manual mouse handling for this particular non-toolkit based utility, it's kind of an older utility, eventually I'll upgrade it to use toolkit, it's going to point to a routine that is within the utility itself, proc mouse. However, in order to link into the utility framework and get all of the utility framework's features, such as control clicking on the title bar to shade or clicking on the close button to close, the very first thing that our mouse handling routine will do is call UFP moose. Okay, but when we come back, it returns with the carry set or clear based on whether you have clicked on or clicked off of the utility. Well, that's actually another thing the utility framework does, is it does the bounds checking on whether you've clicked inside or outside the bounds. It can also re-normalize the event coordinates from being oriented on the screen to being oriented on the origin of the utility. So that's kind of cool. And it'll also, PMoose also does the panel focusing and unfocusing automatically. So we link into all that simply by jumping to UFP moose as the very first step. Now, if it comes back with the carry clear, that means that we're in bounds. So we'll go branch carry clear, star plus 3. And so star plus 3 is just a quick little 1, 2, 3 to skip over the RTS. Now, that means that if the carry is set, it's going to return automatically. Now, why? Because it's out of bounds. So we need to propagate that event because we've clicked out of bounds, so we need to propagate the event. Okay? But in order to propagate the event, all you have to do is return from this routine with the carry set. But the carry already is set if you're out of bounds, so all you have to do is return. So I usually put a note here that just says propagate events. Okay. Now, so now all of this L down, L track, L up for drag start, drag do, drag it, that's all handled by this. So I can get rid of most of this crap here. But I do still have to handle L click because it does manual things. Okay, so I will, I'm going to replace this getMooseRC, which is the old function name, the old routine name from the old static file. I'm going to rename that to UF MSRC. That's mouse row column. So that's going to get us a mouse event, but rather than the event being, a standard mouse event consists of the accumulator, which holds the event, plus the high bit is the X coordinate precision. So the x coordinate is more than 8-bit, so the 9th bit is in the high bit of the accumulator. And then x and y are the pixel coordinates of the event oriented on the screen where 0, 0 is up here. UF MSRC, that's Utility Framework Mouse Row Column. So what that does is it converts the x and y values, it converts them into textual rows and columns, which is often what you really care about. And it normalizes those rows and columns automatically for you, not on the screen origin, but on the origin of wherever the utility is. Okay. However, one thing it does, maybe I should add this to the utility framework, but it leaves the high bit in the accumulator. So we're gonna mask away that high bit just so that we get only the event. Now the switch is kind of cool, but I don't really need it, so I'm just gonna compare to L-click. Okay, and if it's not L-click, I'm just gonna bounce 5. And if it is L-click, I'm going to jump to check click. Okay, so the 5 is going to go 1, 2, 3, 4, 5. So that basically just like this 3 skips over 1 byte worth of data. This plus 5 skips over 3 bytes worth of data. 1, 2, 3, 4, 5. And so if it's not a click, we don't give a crap because the only thing that this thing supports is clicks. So we are going to, we do not want to propagate the event. Now, why? Because there's been some kind of a mouse event, like maybe it's a right click. But we already know that it's in bounds of the utility. So the guy has right-clicked somewhere. If we get to here, the guy has done some kind of a mouse event that's not a click, but it's inside the bounds of the utility. So we don't want that to pass through the utility to the underlying application. Well, maybe you want it to. Maybe you want it to, but usually you don't, right? So we're going to clear the carry. We're going to clear the carry and RTS. I'll put a note on that says stop propagation. Okay? And now we can get rid of all this crap. Get rid of all this boilerplate. Isn't that nice? And we can get rid of the switch macro, which the switch macro is super convenient, but it's a macro, so it actually expands into a chunk of code that we don't need. So here's our check click routine. Now, we don't need this macro do close because that's already handled by this utility framework call. And also, this UF MSRC has set X and Y. So X and Y, the X and Y coordinates are being passed in here. So I like to add, I'm going to add a little comment here just saying that X is the column, Y is the row. Okay. And you can see that we're already automatically doing various checks to see where the guy's clicking. Now, as it happens, I don't need to, actually, that's it. I don't need to change any of that stuff because it works exactly as it did before. At the bottom of this routine, it's going to stop propagation. So even if you have done a click, but you didn't click on something meaningful, it will stop propagation at the end so that the click itself also does not pass through the utility panel. Okay, so that should be it for upgrading ProcMouse. Next, in the old, these two are for handling keyboard shortcuts. Those are like meta key combinations. And the next one is for handling keyboard events that are not meta key combinations. So we're going to stick in here the utility framework routine for handling keyboard commands. And that will allow us to link into, for example, pushing Control W toggles shade. So if I didn't call this, if I don't link my screen layer into the utility framework's keyboard command handler, this utility would not have the ability to Control W to shade or Commodore W to close the window. And similarly, I can do this. Kprint, sorry. So that would link into the utility framework's ability to handle key, non-meta key presses. However, the only thing that handles is forwarding key events to the toolkit. But this isn't a toolkit-based utility, so I can leave this as setCarry RTS. The setCarry is going to propagate the event. So basically, when you push keys, even when the utility panel is in focus, when you push keys, they pass through to the underlying application, the layer that you see behind it. Now you might think, well, is that right? But I actually, that is the way that I want C64 OS to work, because I want the sort of floating panel to be a floating panel. And if you, even if the panel is in focus, it's like a floating palette. It's not like a window. It's not a window that belongs to another app. It's like a floating palette. Okay, so that'll handle the screen layer. So now I go back to my list here just to make sure I'm not forgetting anything. So we've already done conf start to config. We've gotten rid of the conf file. We've checked for conf dirty. Okay, so now we move on to the init and quit routines. Let's check out our quit routine. Whoa, that's a long init routine, isn't it? Yeah, look at this. Quit routine is only one line. So my standard has been to move the quit routine above the init routine. I've done that with all the other utilities. So we'll just get rid of that ext quit. So what it used to be is that the static code that was included here, it had routines called init util and quit util, and at certain points those routines would call ext quit and ext init, which stood for extended init and extended quit. That was kind of crappy. So now these exports, that they still call init util and quit util, except instead of being inside that static framework file, they are now just routines that are in this file, which frankly is a lot more straightforward. So we will simply make we'll make a quit util here. Okay, and the only thing I actually have to do for this particular utility is just jump to uf quit. Okay. Actually, now in this particular case, because I do so little, I don't even have to put it here. I can actually just put uf quit here. I think that'll work. But if I wanted to have any other operations that I do on quit, I could put them in here and call quit util. Okay, so I can get rid of that. So this ext init is going to be called init util. Now, one thing that the old static file used to do, but that I now have to do manually, is I have to initialize the xterns. So xtern is a label down here, and this is a table of the kernel calls, the C64 OS kernel calls that this utility links to. So initializing the xterns dynamically links this utility to the kernel. So we'll come back to this later. But essentially, we just have to do this, init xtern. And that will link this utility to the kernel. Next, we're going to take these options that I made note of, and we're going to pass those as flags. So those are the flag names. So we're going to pass those as flags into the UF-init. So we don't need that anymore. There are some other options here that I'm not using for this utility, but one, if your utility is purely toolkit, you can pass in an option to have the utility framework clear the buffer for you, just to get it prepared. I used to do that manually. Now the utility framework can clear the buffer for you. Now the reason why that's an option, why it doesn't clear the buffer automatically, is because non-toolkit based utilities and hybrid toolkit, non-toolkit utilities statically lay out characters in the backing buffer. So because this is not a toolkit-based utility, we do not want the utility framework to clear the buffer, because when we come down here, you can see that the buffer has, this is data that's manually laid out in the buffer, the backing buffer. That's what actually gets drawn on the screen. So in this particular case, we do not want to clear the buffer. We want the config data, this position of the thing, to be global. So no matter what application you're in, we're going to retain the position that we last saved. So we open the utility and then we move it to somewhere else and we close it, and it's going to save where it was positioned. And the next time you open it, it'll reposition it there. That position is global. So that's what that does. Swap icon is because we're going to use custom icons. We're going to use custom characters in this utility, and we need to back up a portion of the character set, and then at the end we want to restore the backup. So that's what swap icons does. The rest of this should just work. We don't actually have to do anything for the rest of all that stuff. So we could just, excuse me, we could just go back to our list of things to do. The old static utility framework file defines one heap memory page that gets allocated as with a variable called mempage. So the way this works is that the utility gets assembled to underneath the kernel ROM. So utility base is actually E000. And of course, you can also make variables such as these variables and these variables. But these are statically allocated, right? So these draw context variables, this draw context struct, statically allocated memory. And therefore, these variables are under the kernel ROM. So that's okay for some variables, but there are also some variables that really just don't play nicely with the rest of the C64 OS kernel if they're under the kernel ROM. So so basically the utility framework always allocates one heap memory page from main memory, just one page. And it writes some default stuff into that memory page. And you can use that memory page for whatever you want. You can just use it as some random storage for your utility. But that's what it is. But the old static utility file used to call it mempage. It's like a mempage. That's kind of weird. So I changed it to call it metapage because I thought, I don't know, I just liked metapage more. So I'm going to upgrade this from mempage to metapage. Mempage, metapage. Okay, so that's it, just 2 references. All right, what else we got to do? Yeah, okay, so next, if we were manually clearing the buffer, we can get rid of that and replace it with that flag here to clear the buffer. But we're not manually clearing the buffer in this utility. The other thing that we can do is the new utility framework draws the title bar. But in this particular utility, because it's quite a narrow utility, let's just go down there to char map. About app. Is this about app? No, this is not even about app. It's about C64 OS. Char map. So this comment is actually out of date because I copied this code from the about this app utility. C64 OS. So this data in here, this is actually hard-coded data. Now, is that brutal? Yeah, that's brutal. That's why the new utility framework does this shit for you so that you don't have to do this. But 6E is the character for the close button. 6F is the stripes. A0 is a reverse space. And then these bytes are 1, 2, 3, 4, 5. So that's only, it's about. I'm sure, I swear to God, it probably just says about. Yeah, that's what that is. That just said about. Yeah, and then another reverse space, and then 2 more grippies, and then 60s are transparent. That's what gives, this is what allows any 60s in the backing store buffer, they don't, when the backing store buffer gets composited onto the screen, it doesn't copy those bytes. And also when you click on the buffer, if you click on something that's a 60, the click will automatically pass through the utility as though it was out of bounds. So that's kind of cool. You can make transparent areas in your utility. That's really cool, eh? So you can make a utility that's like a wacky shape, which is pretty rad. If you ask me, it's pretty rad. But because this utility is so narrow and
name of the file is so long. I don't want to use the convenient feature of the utility framework to draw the title bar. So I'm just going to leave that as it is. Same with the color maps title bar. So the color maps, go down here to the color map. These 67s are the color code, the 6, but then the 6 sets a high flag, and then the 7 tells you that it's going to get, this is not a static color. This is a color that comes from the themed color. So if you were to just put in a number like 5, okay, 5 would be a static color, or 7 would be a static color, but because it's 6, 7, 60, oh, that's by the way, that's not hex. So 67, this is stupid too. This is an old utility where I was putting in things not in hex. Sorry, so 67 in hex is 43. Yeah, so the 6 in hex, if it was a 6 in hex, like this guy here, that sets bit, what bit does that set? 60? 60 in hex sets bit, sets one of these super high bits. What is that? 0, 1, 2, 3, 4, 5, 6. Sets bit 6. And bit 6 and bit 5. 0, 1, 2, 3, 4, 5, 6. Yeah, it sets bit 6 and bit 5. Anyway, one of those two is used for the transparency. This 67, though, that's decimal 67. Sorry, that's decimal 67 is actually hex 43. So hex 43, if we convert that to binary, this bit is being used, so 0, 1 for these high bits means that it's a toolkit color. And then 3, this 3 is the third toolkit index. And that, if we were to look it up in our notes, that is PanelTitle. Wherever that is, who cares? I've got it as a note. But that's 3 is PanelTitle. So these characters here basically define this many bytes as being PanelTitle color from the theme. And then these two 60s are transparencies again. If we were setting the title using the utility framework, you don't have to worry about any of that shit anymore. The utility framework actually takes the transparency, the utility framework figures out how long the title should be and how much of it should be transparent, and it sets the color maps transparency for you. Okay, so the very last step here, the only other thing to do is to remove unused kernel calls. So because the old utility framework was a static file, I had to put kernel calls into the bottom of this file that would be referenced by that static file. That kind of sucks. It bloats up the code. Takes longer to assemble. Now, the new utility framework, it makes its own, it actually links to the kernel on its own. When it gets loaded, it dynamically links itself to the kernel. So it has its own table like this. And what's great about that is that the only calls that we need to have in here are calls that are explicitly made within this very file. So for example, we can search for, let's start down here, set context. So we'll go and we'll look for set context. And lo and behold, just as I suspected, set context is not being called directly by this file. It was only being called by the old utility framework. It's still being called by the utility framework, but that's now inside its own self-contained assembled unit of code. And so we don't need it here at all. And so we can, not only do we get rid of that link, but we also get rid of the header include for toolkit, which it came from, and that makes compilation faster. Next, we'll search for pet to screen, but I'm pretty darn sure that is being used. We'll go pet to screen. Indeed, it is. So we'll jump to the pet to screen label, just to get us back down here. So we need our string header and our pet to screen link. Next, we're going to look for get SFRef. Get SFRef. That's no longer being used, so we can get rid of that. Load util, I believe, is not being used, so we'll look for load util. Don't think that's being used anymore. It's not, and so we get to get rid of this service header as well as the link. So that's going to be better. I guarantee to you we're not using layer push or layer pop or context to screen. Those were all part of the framework for pushing the layer and popping the layer when you quit and load the utility. Screen row, I'm pretty damn sure we don't use anymore. I mean, it's still in the utility framework, but it's not in this file directly. And redraw as well. We're not going to use that. We can search for it for fun, but we're not going to use it. Okay, so that's mark redraw. Search for the next instance. There's mark redraw. We're not using the other version of redraw. Okay, so we've reduced screen to just one link. Like that's great. Now malloc and free we definitely use within this file. Page alloc. Holy Christ on a crutch, we don't use it in this file. How about page free? We do use page free, but we do not use, we use page free. Why do we use page free if we're not using page alloc? Conf fref. Oh boy. Oh boy. Oh boy. Yeah, so we might run into a slight complication here. What is all this stuff doing? What is all this stuff doing? This utility indeed. Version file. Right. Right. So the utility about C64 OS loads in the version file from the settings directory. Let's just check for ver file here. Yeah, it loads ver.t. So let's, this is quite unusual. So let's save this. Let's just save our changes. We're going to save about C64 OS.a. And let us pop over to the S folder, clear this, and load in utility.s. This is the old static utility file, utility framework file. And we literally have just this one solitary utility that's still using it. But I haven't deleted it yet because I've been wondering whether I'm going to need to find anything in it that might be useful. I think this might be an instance. So that was conf-fref. Indeed, there it is. Yeah, right. Mm-hmm. You know what I'm going to do? I'm just going to grab this routine. I'm going to grab this routine and I am going to I only actually need, so this is in the static, the old utility framework static file. It was used to configure the file reference to the config file that the utility would use to save its state. And it has these conditional assembly statements. So if conf glob was if global configuration, it would allocate a page of memory and configure it with the settings path and so on. If it was not a global configuration, it actually grabs a reference to the current application's file reference, which is a file reference to its bundle. And then what it would do is it would take conf file, which was also defined in the utility, and it would copy that to be the file name of the file reference. And then boom, it could use that to save or to load its config. All that stuff's now handled by the new utility framework. But in this particular utility that I'm upgrading, it was also using this routine, knowing that this utility is globally configured to get a file reference to the settings folder so that it could grab the version file. So I'm going to just copy this code from here to here. Copy name. Yep, copy names right here. And I'm going to pop back to the utilities folder. And I'm going to write this selection out as a clipping. Oh, file exists. What's my clip? What's my clip currently? I don't care about that. So I'm going to write this file out as, I'm going to overwrite clip.t. We're going to load in about C64 OS.a again. We're going to look for page free. We're going to look for conf-fref. And we're going to load in that clip that we just copied from the other file. We're going to move set path up to here. Oops. Okay. We no longer care that for that conditional assembly. Get SFRef, however, I need that again, don't I? Yeah.
I'm going to get rid of this. Star plus 1, 2, 3, 4, 5, 6. Get SFRef. I need that now, don't I? Again. Crap. And I deleted the link. All right, no problem. So it comes from service. We can check that out, by the way, by going to our headers directory and looking at service. And we can see that get SFRef comes from service. So that's no problem. We can just bring that back in. We'll just go inc header service. And then we'll go get SFRef. It's a syscall to the L service module, to the service lookup. Get SFRef with an underscore. Okay, so now we got get SFRef back. So what this does is, so this is our page alloc. When we pass in a 0 in the y, we pass 0 in y, and that tells get SFRef that we want it to allocate one page for us for the system file reference. Then we stash that page, pointer to that page in pointer, and then we can append the path, set path, so we just loop over that, appending set path. And then we get down here to FRef name, and we're going to copy the version, the file version. Yeah, so I think that's all we need to do for that. Okay, and so, okay, and so now we're back here to our page alloc, right? We wanted to know, do we use page alloc? No, we don't. But we do use page free, and then the question is, why do we use page free? Because get SFRef allocates one page, but we don't need it for more than just reading in the version file. So we open and read the file, and then we immediately free it. Okay. Okay, so 2 hex, do we use that? Well, probably, right? Why not? We were using that before, yep. 2 hex still being used. Okay, now do we use ReadMouse? ReadMouse? Probably not, because the utility framework does it for us. Do we use mouse RC? Almost certainly not, because the utility framework does that for us. Do we get a read K command? K command? No, we don't use that anymore either. So we can get rid of input. Now, we do use fopen, fread, and fclose. That's for getting the version, but I don't think we need fwrite anymore. That was used for writing out the config file, but that's handled by a utility framework. All right. So there you go. We've just reduced the number of kernel calls that we need. Fopen, fread, fclose, 2 hex, page free, mark redraw, get a system file reference, and do Petsky to screen conversion. And that literally is it, I think. So we will save this. C64 OS.a. Now what we're going to do, we're going to take a look at how big this is. So it's 28 blocks. And also, we're using 167 labels. So what we're going to do is we're going to write this file out to temp.t. So that writing a file out is different from saving a file. When you save a file in Turbo Macro Pro, it saves the binary version of the file, which is smaller. But when you write out a file, you write it out as Petsky. So now we'll clear the buffer, and we will enter the file we just saved. So that's going to load in the Petsky and convert it into the internal
Turbo Macro Pro binary format. But the other thing that will do is it will completely rebuild the label index. But because I've been fucking around with the labels for so long, I really want to clean up that whole labels internal index. So there you go. So we used to be using 167 labels. Now we're only using 109. And this used to be 28 blocks. Now we'll save it with the new binary, with the freshly rebuilt binary file from the text. And we'll check and see if it got any smaller. Indeed it did. Now it's only 26 blocks instead of 28 blocks. So that's kind of cool. We can scratch that temp file. Okay. And now we're going to build the object file. Now the object file has to be built to match this identity name. So when we build our object file, it will be about space C64 space OS, all caps with the spaces. And I'm likely going to cut this segment of the video out because it takes a long time to assemble. So see you in a moment. Okay, we're back. Assembly is completed, and as you can see, there are 0 errors, so that's a good sign. Next, we're going to try booting up C64 OS. We're going to hope that it doesn't explode in colors. I don't think it will, I gotta be honest. Okay. Now, how do we get to that utility? About this app, that's not it. We can get to it with settings or utilities. So it's this about. So click that. There you go. Of course, it's fucked up all these things, eh? But, you know, whatever. That's a different problem for a different day. Ah, you know what I should have done? Should have changed this year, 2020. Should have changed it to 2022. And then this V 0.7 beta. So now you can see that the keyboard shortcuts are working, by the way. And you can see that the panel is, title is changing when we focus the panel or don't focus the panel. So 7 beta, oh, we can also click on these. Okay, so that's kind of cool. And we can hit Command or W to close that. So 7 beta, and the icons got restored. Why don't we pop into settings, find version, take a look at that. There you go, 07B. So that's where the version number came from. So there you go. That was the last utility that I had to convert, and that's probably where I'll leave this video for now. 1 hour, it's pretty good. I guess the last thing that I'll do is I'll probably change that copyright to 2022. And I got to update the version file to be version 8. Thanks for watching.